Alright, in this video we're going to talk about average acceleration, which is nothing more than the change in velocity over the change in time. So as we look at these practice problems, we'll have to incorporate those variables. Okay, the first practice problem is a Saab advertises a car that goes from 0 to 60 miles per hour in 6.2 seconds. What is the average acceleration of this car? 60 miles per hour in 6.2 seconds. Okay, now, remember, average acceleration is change in velocity over change in time, so it's the velocity final minus the velocity initial. So initially it talked about the car going 0 to 60, so its final velocity would be 60 miles per hour. Its initial velocity was 0, so we're dealing with a 60 mile per hour velocity here. Now, and the time elapsed is 6.2 seconds. Here's the problem. We have miles per hour and seconds. Well, just remember that average acceleration is calculated, the units are meters per second squared. So we need meters per second, not miles per hour. So the first thing we're going to do is have to convert those 60 miles per hour to meters per second. I'm going to set that problem up real quick and I'll come right back to you. Okay, now I have this problem set up, 60 miles per 1 hour. That's all 60 miles per hour is. So if you set up T-charts to do your conversions, that's absolutely fine. I set up fractions with conversion factors. So we need to convert from 60 miles per hour to meters per second. And the way we do this, we have to convert miles to meters by canceling out miles, and we have to convert hours to seconds by canceling out hours. Now, if you didn't have a conversion factor, most of these problems will give you a conversion factor. If it does not give you a conversion factor, just go with what you know. We know there are 5,280 feet in a mile, and we could go that route. But if you look, the second problem on here tells you there's 1 mile for every 1,609 meters. So 1,609 meters equals 1 mile. So we're cheating by looking ahead and seeing that. Instead of going feet to inches to centimeters to meters, we're going to go straight from miles to meters. So 1,609 meters per mile. So I'll bring my units down, miles, so they'll cancel out, and I'll go straight to meters, or I could have put little m. But remember, it was 1,609 meters per 1 mile. So now, our miles cancel out, and we're in meters, but we're in meters per hour. So we need to go ahead and convert hours to seconds. And if you didn't know, there are 3,600 seconds in 1 hour. If you didn't know that, you could just go hours to minutes, which would be 60 minutes, and then minutes to seconds, which are 60 seconds. So 60 times 60 would be 3,600. So you'd end up there anyway, but this way you can skip it. If you just put this to memory, 1 hour is equal to 3,600 seconds. And then hours cancel out. Now we're in meters per second. So let's go ahead and calculate that real quick. So I'm going to calculate 60 times 1,609, and then on the bottom is 3,600. So I'll just divide by 3,600, and that gives me 26.8. 26.8 meters per second. So that is my converted speed, my final velocity in this case. So we need to go average acceleration equals change in velocity over change in time. Now, it was 0 to 26.8 meters per second, so final would be 26.8 minus 0 is going to be 26.8. So in this problem, our average acceleration equals 26.8 meters per second, and it was over 6.2 seconds, if I'm not mistaken. Let's look back real quick just to verify. And it is 6.2 seconds. So 26.8 meters per second in 6.2 seconds. And if you look back, now remember, the units of acceleration, average acceleration, are going to be meters per second squared. So if you look at the way this problem's set up, you can know if you're setting it up correctly. Meters per second. That's meters per second squared. So it looks like we're on the right track. I like to do sanity checks like that along the way just to make sure you're setting it up correctly. Now let's get the average acceleration here. It's 26.8 divided by 6.2, and that comes out to 4.3 meters per second squared. And that is my average acceleration for this side. Alright, our next example. An airplane has an average acceleration of 5.6 meters per second squared during takeoff. How long does it take the plane to reach a speed of 150 miles per hour? And remember, 1 mile equals 1,609 meters. Now we know when we're dealing with acceleration, we're going to have to be in meters per second and meters per second squared, and for time we'll have to be in seconds. So if you're given any other frames of time or speed, anything like that, you will have to convert back to our SI units. So let's see. We have an airplane taking off 5.6 meters per second squared. It needs to reach a speed of 150 miles per hour for takeoff. How long does it take? So we're going to be solving for time. So if we look over here, now, if we look over here, we see we have our acceleration, average acceleration formula written down. Average acceleration equals velocity over time, change in velocity over change in time. We need to solve for time. So in order to rearrange, we're going to multiply both sides by time, and then we need to get time by itself, so we'll have to divide by accelerations. So what you'll end up with ultimately is time equals your change in velocity over your average acceleration. And this will be change in time. Change in time equals change in velocity over your average acceleration. So let's just plug in our numbers here. Delta t equals our change in velocity. If we look back, our change in velocity, it goes from 0 to 150 miles per hour. So 150 miles per hour would be your final velocity. So we just need to convert that to meters per second. So because you're obviously starting during takeoff at 0 miles per hour. So 150 miles per hour is your final velocity. 0 miles per hour is your initial velocity. So we just need to convert 150 minus 0 equals 150. Convert that from miles per hour to meters per second. So let's go back over here. And let's put it off to the side over here. So 150 miles per 1 hour. And we learned a minute ago, how many meters are in 1 mile? 1609. So come back over here and we'll bring down miles. 1 mile is equal to 1609 meters. And then hours to seconds. I told you if you commit this to memory, it's going to save you a couple steps and some time, and a chance to make an error in your calculator by having to put one more step in there. So 1 hour equals 3,600 seconds. And if we do our math here, 150 times 1609, let's turn it on first. 150 times 1609 divided by 3,600 equals 67.0 meters per second. Okay. Can't see that, can you? 67.0 meters per second would be our velocity. So I'm going to plug that in right here, 67.0 meters per second. And we're going to plug in our average acceleration, which was 5.6 meters per second squared. And that equals 67 divided by 5.6. 11.96, which we'll just round up to 12.0 because that 6 is going to round the 9 to a 0, carry the 1, 12.0 seconds. And just remember, meters per second is going to cancel out meters per one of these seconds, and you're just left with seconds as your units. So 12 seconds is how long it will take that airplane to accelerate to 67.0 meters per second, or 150 miles per hour. Okay, the third problem. If we look on here, a train moving in a straight line with an initial velocity of 0.50 meters per second accelerates for 2 meters per second squared for 2.0 seconds. Da 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 da. Okay, look, these videos are only 15 minutes long maximum each. We've already reached the 10-minute mark, and since this will be involved, I'll involve graphing on this next video for this next problem, and then solving the problem with mathematics. We're going to go ahead and cut this video off at this point, and I will make an entire video for the third problem. That way I can take my time with it and show you how it's done.